أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Thanks to Allah subhanahu wa ta'ala for all his blessings and bounties that he has bestowed upon us. فَبِأَيِّ آلَاءِ رَبِّكُمَا تُكَذِّبَانِ. Today still we are going to talk about Fourier series. We got an idea about the Fourier series. It's all about the infinite geometric series. We obtain a series solution. How do we find it? We have to find cosine terms. We also have to find terms involving sine, because this is how the formula is a for any periodic function which is going to be periodic of period 2 pi extended over the interval from minus pi to pi. So all we need to calculate a naught, an, and bn. A naught is going to be a part of an. So effectively we have to calculate an's and b's for all sort of integral values of n, positive integral values or natural numbers, 1, 2, 3. Formulas are there. A naught is a an and bn. So how do we calculate them? So these are the formulas for a specific interval. When we talk about an interval of length 2 pi extended from minus infinity to infinity. We could also look into the alternative intervals. An interval extended from 0 to 2 pi, for example, or minus 3 pi by 2 to pi by 2, for example. So how we do that? So by extending an interval from c to c plus 2 pi, by taking certain values of c, like minus pi, you will go back to the previous formulas. Or if you take c equal to 0, for example, so it is an extension. The interval is extended from 0 to 2 pi. So we got an idea. How do we find infinite geometric series? All we need to calculate coefficients, a's and b's. They will take us to the terms involving sines and cosines. But when we talk about Fourier series for an even and odd function, we can reduce the computational cost by avoiding unnecessary calculation behind the scene. The idea is that, first of all, you need to see whether the given function is even or odd. So based upon that, we will eliminate some of the coefficients. If a function is even, then only we need to calculate a naught and an. Means bn is going to be 0. Only we need to calculate a naught and an. This is the generalized interval from extended from minus L to L for a period of 2L. So Bn is going to be 0. So we see that yes, the computation cost has been reduced significantly. If you ensure that before going to find the Fourier series of the given function, whether it is even or not. If it is even, directly we can say that yes, Bn is going to be 0 and the reduced form or the corresponding form of the Fourier series would be like that. So in this formula, all we need to calculate a naught and an. Whereas if the function is an odd function is there, then only we need to calculate b's. Same formulas are there. A naught and n, they are going to be vanished. And the corresponding form of the formula would be like that. So it will involve only sine term, together with these arbitrary constant or coefficients. So we see that yes, the computation cost has been significantly reduced when we take into consideration whether the function is even or odd. So we will also exploit this idea while talking about half-range Fourier series. Over the previous lectures, we have seen that whenever we talk about a Fourier series, so it is going to be extended over the interval minus L to L, minus pi to pi. So it's a complete range of periodicity where we see that the function is going to be periodic over the interval either from minus pi to pi or in general from minus L to L. But sometimes things are slightly different. We cannot observe whether the function is even or odd from the given expression or from the given part of the domain or from the given portion of the graph if you look geometrical aspect. So then what are the options behind the scene? Again, I reiterate, when we talk about Fourier series for an even function, it will involve only cosine terms. And if the function is odd, the Fourier series will involve only sine terms. So keep an eye. We will talk about this later. For even function, series will involve cosine terms. For odd function, series will involve only sine terms. All right, so we are going to talk about half-range Fourier series. It's half of the interval. And then how do we cope up with the idea of an even or odd function? We need to extend with the extension all right. So we will take an advantage of this idea for a series against an even function or a series against an odd function. So we look into the description first. Why do we need of half-range series? Why do we look into that? In many problems of physics and engineering, there is a need of use the Fourier series of a function that is defined only on the interval from 0 to L. What we have seen so far, every time the interval would be minus L to L or from 0 to 2L, a complete description. But over here we see that this is going to be the half of the interval. We know that the Fourier series of an even function is a Fourier series that contains only cosine terms. So this is how it could be named as Fourier cosine series. Whereas the Fourier series of an odd function will involve only sine terms, so it could also be regarded as Fourier sine series. We use these features of even and odd functions to obtain the half-range Fourier cosine and sine series respectively. So we will take an advantage of this feature of an even or odd function because what we observe, if we describe the function before going into the calculation of the series, whether it is even or odd, the computational cost is going to be significantly reduced. So we will take an advantage of that. First of all, we look into the half-range Fourier cosine series. Half range, remember, because the interval is given only half of the period. Period is generally extended from minus L to L. Suppose that the half-range Fourier cosine series is desired for a function which is defined over the interval from 0 to L. So, idea is there, we have been given a function which is extended from 0 to L. So what can we do with that? So here you go. So it is described over the interval from 0 to L. Remember, if you look into the geometrical aspect, we can't describe it, whether it is even or odd, but we can make it. We can make it an even function as well as we can also make it an odd function. I mean, depends upon the extension. What are we looking for? For an even function, we will be having cosine series because it will involve only cosine terms. And if it is desired to find Fourier sine series, so surely it will involve only sine terms, and behind the scene the function has to be an odd function. So we can make this portion of the graph as an extension, as an even function or even an odd function. What is an even function? It should be symmetric about the vertical line, about the y-axis. Same portion of the graph should lie on either side of the vertical line. Whereas an odd function is going to be symmetric about the origin. So same portion of the graph should lie in the opposite quadrant. If we have a portion of the graph in the first, so the other one should lie in the third quadrant. So this is all. It will be symmetric about the origin. So we have this portion of the graph, and we are interested to find its series. And we know that Fourier series is going to be discussed only if the function is periodic. It is not going to be periodic. You see that this portion of the graph is not going to be periodic because geometrical aspect states that the same portion of the graph is going to be repeated over and over again. So what we see, we have to extend our journey over the other half. How we do that? So this is going to be the first reference figure. So what is the idea? The function is defined over the interval from 0 to L, as shown in the following figures. Figure is there, reference figure is there. You have to take a note. What the idea is here with the half-range Fourier cosine series. Since a Fourier series is obtained only for an even function, therefore, why do we call it an even function? Because we have to talk about cosine, Fourier cosine series, and cosine terms are only involved when the function is an even function. In other words, if you come round the way, if you have to find the Fourier cosine series, so it means that the function has to be even. You have to make it an even function. We know about the geometrical as well as mathematical aspects of an even function. Therefore, we extend the function f of x over the other half of the interval from minus L to 0. So what we have been given, over the interval from 0 to L. So what we do, we extend the portion of the graph to other half of the interval minus L to 0. So this is how we will make it an even function, because eventually we have to talk about Fourier cosine series. Cosine series is connected with the even function. Interval is given from 0 to L with a certain portion of the graph f of x. We extend this function over the other half of the interval from minus L to 0. So in this way, with this extension, f of x is going to be an even function which is going to be defined over the interval from minus L to L. So this is all. A periodic function with period 2 pi will be observed. We have been given f of x defined over the interval from 0 to L. We extend the portion of the graph to the other half of the interval from minus L to 0. So in this way, the function will be defined over the interval from minus L to 0. So when the function is defined over the interval from minus L to L, we will see that yes, now it is going to be a periodic function with period 2L. So how we look into the graphical representation. Okay, so now we are going to extend this one. We have to extend right. So what we do, we have to extend this portion of the graph. F of x initially was defined against the interval from 0 to L. Now we have to extend to the other half. So minus L. Now in this way, we see that yes, it is going to be symmetric. Symmetric about the vertical line. Going to describe an even function. Now function is going to be an even function which is with period 2 extended from the interval. Yes, is there any query? Just raise your hand if you are interested to ask something. $56. Do you have any question? Otherwise, turn your microphone off. Let me mute all of you again. They're all muted. All right, so we got an idea got an idea how do we extend the portion of the graph. Initially, it was given only against the interval from 0 to 12, but we take an advantage of an even or odd function. So what we do? We extend the portion of the graph to the other half of the interval, extend it from minus L to 0. No, clearly it is going to be an even function. Because geometrically, it is symmetric about the vertical line, same portion of the graph lies on either side of this vertical line. And when the function is periodic, on top of that, it is even. We know how do we find the Fourier series? We know from the previous lectures. We can now represent this extended function by a Fourier cosine series given by. We know that if a function is periodic with period 2L, for example, extended over the interval from minus L to L, on top of that, it is even, then the corresponding series would be like that. All we need to calculate A naught and AN. Bn is going to be 0. Formulas are there for A naught and AN. Bn is going to be 0, surely. Since the Fourier series, that one, number 16. So you see that it will involve only cosine terms. It's based on the function f of x defined over the interval from 0 to L, which is half of the interval of periodicity minus L to L. I mean, this is all. The function is going to be periodic. So function would be periodic over the interval from minus L to L. This is how we make it. Initially, it was given against the interval from 0 to L. Therefore, this series is called the half range because the interval is half of minus L to L. The half is going to be 0 to L. So this is how it is known as half range Fourier cosine series. Eventually, it is going to be Fourier series for an even function and will involve only cosine terms. So this is how more precisely Fourier cosine series. But since we take start by taking only half of the interval, so specific name is a half range Fourier cosine series. Pretty much on the same line, we can talk about Fourier sine series. But before we move on, I generate a poll for attendance purpose. things have been modified. Okay, I need to see how can we generate a poll for attendance purpose. So they have added features over there. I mean, the outlook is going to be different now. So how we do that? Actions. Does anybody know how to generate a poll in this feature? Yeah, I know that. I mean, these are the dots, but there is no option for the form. Initially, it was there. We used to do that. Okay, general meeting, general setting, and turn off new meetings. Okay. Attender list, yes, it could be downloaded once it is marked. I mean, you can download at any stage, but initially you need to generate it. Okay, first of all, we complete the lecture and then I see how can we do that. Okay, remaining lectures are uploaded on YouTube, I believe that. Quite a few lectures are there. Even the last lecture has been uploaded. All right, so first of all, we complete it. Before we move on, got an idea about the Fourier series, Fourier cosine series. We see that if the function is described or defined over the interval, like from 0 to L, we can extend to the other half of the interval so that it will be described over the interval from minus L to L. In this way, we will be having the periodicity, the interval of periodicity, where the function is going to be periodic. This portion of the graph is going to be repeated over and over again, with the advantage of that having an even function. With even function, we know only a naught and an to be calculated. Pretty much on the same idea, we can talk about Fourier sine series described over the interval initially. I mean, the interval is given from 0 to L. Suppose that the half-range Fourier sine series is desired for a function which is defined on the interval from 0 to L. And then we need to extend it. Because the idea is that for an odd function, we will be having a series involving sine terms only. So what we do, we extend the function over the other half of the interval so that it becomes an odd function. So you have to make it yourself. With this extension, f of x is an odd function defined on the interval from minus L to L. Then extend this new function as a periodic function of period 2L. And then further we can look into the formulas behind the scene. Formula is there for the Fourier series. It will only involve b's, bn to be calculated roles order values of n, positive integral values. And eventually you see that it will involve only sine terms. So how do we look into those figures? So initially, same idea is there, same thing is there. We have been given, let me erase. We have been given only this portion of the graph. F of x is defined against the interval from 0 to L. And we have to extend this one over the other half from minus L to 0 to ensure that the function defined over the interval from minus L to L is going to be odd. For half-range Fourier sine series, the function has to be odd. Odd means geometrically, graphically, it should be symmetric about the origin. Same portion of the graph should lie in the first and third quadrant. I mean, if this is an image, so pre-image should be there in the third quadrant. So how we do that? Let me try and see if I can make it in the best of the way. I'm not good at drawing, so let me do that. Does it make sense? No, not really. So effectively, we have to make it something. Something like that. Yeah, that's better. Okay, now we see that. Yes. The function initially was described over the interval from 0 to L has been extended. So initially it was described over the interval from 0 to L, but now we have extended. We have extended to the other half so that it is now an odd function, symmetric about the origin. So depends upon the requirement, what are we looking for? So in this case, we are desired to make it half-range Fourier sine series. So sine series will involve only sine terms, and behind the scene, the function is going to be an odd function. So you have to extend the portion of the graph in a way that it is going to be an odd function, geometrically symmetric about the origin. So this is all. The second graph is there, second figure is there. So you need to take a note. This portion is given, and then we extend it to the other half so that it comes an odd function, symmetric about the origin, extended over the interval from minus L to L. All right, so we see that yes, we take stand by talking about the same portion of the graph defined over the interval from 0 to L. We extend it to the other half of the interval minus L to 0 so that it comes an odd function defined over the interval from minus L to L. So we can also extend this idea as a periodic function of period 2L on the x-axis. How we do that? I mean, you need to extend this portion of the graph so initially to the right hand side, for example, let me try and give you an idea how we extend this one. Can we extend this one? Yes, we can extend this one. Yep. So make a line. For example, like this one. So here you go. Here. Like this one. And again, it has to be repeated. This is all. I mean, idea is there. You can make a better graph on both sides. On both sides, of course, it should be there. And there will be a portion of the graph like that. So this is how we will be having the periodicity. I mean, this is going to be the period extended from this point to that point. Yep. So in this case, this is going to be the period, capital P. P is equal to 2L. Period is that portion of the graph is going to be repeated over and over again on either side of this center of the coordinate axis. So initially we had this portion of the graph, we make it an odd function so that it is going to be periodic with period 2L, extended over the interval from -L to L, and then we extend this portion. Again, same portion is repeated twice, thrice, and then so on either side. So this is known as periodic extension. Initially, we extend over the other half of the interval, and then once it is defined over the interval from -L to L, we look into its periodicity. We extend it on either side with that period of length 2L. So in this way, we will be having periodic extension of the new function defined over the interval from -L to L. We can now represent this extended function by a Fourier sine series given by this formula in equation number 17. Only we need to calculate B's, B1, B2, B3, B4. Formula is there. And eventually we see that it will involve only sine terms. In the infinite geometric series, it will involve only sine terms. So this is how it is known as Fourier sine series. But because initially the function was defined over the interval 0 to L, which is half of the interval of periodicity -L to L, therefore this series is called as half range sine series because it will involve only sine term. On top of that, it is going to be odd function behind the scene. So sometime, yes, we can manipulate things in such a way. Initially, it was not either even or odd function, because this is how we can take an advantage. If the function is even, yes, we can take an advantage. For an odd function, yes, we can take an advantage. So depends what are we looking for. So whatever is our desire, we will make it accordingly. For cosine series, we will make it even function. For sine series, we will make it odd function, and then we will utilize those formulas. Particular case of period 2 pi, yes, it's a simple case. I mean, if the function initially defined over the interval from 0 to pi, the half range Fourier cosine series corresponding to f of x is given by this one. So idea is pretty much the same. You need to extend to the other half of the interval from -pi to 0, so that it turned out to be periodic function with period 2 pi. It is not periodic over the interval from 0 to pi. You need to extend it to the other half. So periodic function plus even function. So this is how we will be having this series. A naught to be calculated by utilizing this formula, an to be calculated by utilizing that formula. And the corresponding Fourier sine series, half range Fourier sine series. And how do we calculate B's? So this is going to be the formula. Bn would be calculated by utilizing this formula. Once we have plug in over here, and this is how you will be having the Fourier series. Y is half range because initially the function was defined over the interval from 0 to pi, and you extend it. All right, take an example. Take an example. If pretty simple example is there. The most simplest example that you could imagine, f of x is equal to x. It's a straight line. Straight line. The interval is from 0 to L. So in the first quadrant, this portion of the graph is there over the interval from 0 to L. Then find the half range Fourier cosine series and the half range Fourier sine series. So for half range Fourier cosine series, we have to make it an even function, just like the graph of mod of x, symmetric about the vertical line. And for half range Fourier sine series, it should be a straight line passing through the origin, bisecting the first and third quadrants. So this is how you take start. I give you an idea. The graph of f of x over the given interval from 0 to L. 0 to L is there, so you need to pick this portion of the graph against that interval. It's even extension because we are going to talk about Fourier cosine series. For Fourier cosine series, function has to be an even function and its periodic extension of period 2L. So you need to figure out bigger figure to show that initially it is periodic over the interval of 2L and an even function, and then show its periodicity, extend this periodicity on both sides of the center of the coordinate axis, and then you have to find it. The try try yourself. Try yourself. You also have been provided the handouts. So the idea is there. I mean, just like I give you an idea. For example, it will be something like that. Something like that. Straight line. Okay, I do it with. Straight line. So this portion of the graph is given. This portion of the graph is given. F of x is equal to x over the interval from 0 to L. No, you can make it an even function by taking that portion of the graph, or you can make it an odd function by extend it to the other half of the interval as a straight line. That one. So this is how you take start, and then with the periodicity as an extension on both sides. So this is how you will take start. And then describe, since it is going to be even in the case of Fourier cosine series and Fourier sine in the case of odd function, you have to calculate corresponding A's, A naughts, AN and BNs. So I look into the tennis. How good can